is 2, 1. 2, 1 is going to be like right here. That's 2, 1, right? Mm-hmm. Agreed with that? So fx is where y is constant, right? It's just x. So you're looking for, if you had drawn a tangent line going in this direction. So if this surface was in front of you, you're drawing a tangent line at that point going in the what direction? The x direction. So you're going like right here, like this. So yes, there are no like specifically labeled points. You might not be able to find something even, but you're going to have to estimate. That's it. You're just going to have to estimate. So for example, look for something that you know the definitive values of. You could pick maybe from this point all the way to, I don't know, this point. So if you want to actually find this out, so approximating f, so wrong side, fx 2, 1. What contour, what this blue contour line right here, what value does the blue line take? 4, 5, 6, 7, 4, 6, 8. So what value is this line right here? 10, right? So it's gone from, it goes to 10, and what's this one right here? 2, so it's 10 minus 2 over what? What's that x value right there? What? I think it's 3, and then this one is what? 1. So you could estimate it as 8 over 2, so you could make one estimate as, it's about 4. I chose those because the contour lines look like they definitively go through. Now, you could pick different points. You could zoom in even further, and you could try to pick like this point. Why is working with that point a little harder? Like you know it's 4, right? But what do you not really know exactly? The x value. You have to like estimate this, right? So you might be like 1.6. You understand what I'm saying? So it's up to you. I was having a conversation with Kate about this at the beginning of class. You're going to take some quizzes and tests where I'm going to have to accept 13.1 to 13.9 as the answer, because depending on which points you take, because he was bringing up like, I like taking a point before and a point after. The book likes to take the point and go forward, right? It's up to you. It's going to depend on the contour diagram. And I don't know what the answer book says, but I'd imagine it's around 4. Did anybody check?
The actual answer is 4.
Woohoo! Well, you don't, because you actually did it out?
Yeah.
Okay. So, hey, my estimate was awesome. I love subconscious math. Every once in a while I'll do a question on, yeah. And of the same surface. So you have this surface, and what's going on with each of the other two views? What are we doing? Like, where's your viewpoint? What's happening? Zooming in, exactly. So is this a plane right here? Is that a plane? No, it's not a plane. But what happens as you zoom further and further in? It's getting more planar, right? More planar. You've seen this before in 2 dimensions. You studied this extensively. Hey, here's a curve, right? If you zoom in right here, what do you get? You get something that looks like this. And then you zoom in right here, what do you end up with? Eventually, it looks flatter and flatter and flatter. So you end up looking at a tangent line. So in 2 dimensions, we had tangent lines. In 3 dimensions, what are we going to have? Tangent planes. Contour-wise, here's a contour. Is this a plane right there? No, it's not a plane. How can you definitively know? Why do you know that that's not a plane? The contour lines aren't, the contours aren't straight. They're not lines. But as you zoom further and further in, what do the contours become? So the contours are, there's 3 things that are really important to recognize about them. What's one thing if you want to know it's a plane? First, they are lines. Then what? They're equidistant, right? So not equidistant. They are, yeah, equidistant. And what was that last one? I think you said it, Cade? Parallel. They're parallel. Right? Don't they have to be parallel. We can't have one like going like that. If the distance wasn't the same between them, we might have some wavy thing, right? It might be really nice when you look down below, they're all parallel, but does parallel itself mean it has to be a plane? No, the spacing needs to be the same. The spacing needs to be the same. So, what do we get in terms of a picture? We get a picture that looks like this. There's our surface, and there's a point on the surface. There's our tangent plane. That tangent plane touches the surface how many times? Once at that point. Does it touch anywhere else? No, or it wouldn't be tangent. So tangent planes, how are we going to find them? Well, you saw something that looked like this in chapter 12. Do you remember this equation right here? you remember what M and N represented? Yeah, it was the change in the x direction, right? And what was this? Exactly, change in y direction. Remember, I think I apologized then and I'll apologize now for math in that it's choosing again two letters that sound and look alike. I don't know, P, Q, M, N, great, awesome. Point being, used to be, when we were doing this before, we'd have like a table of values and we'd estimate, or we'd subtract two given points that have the same y value or the same x value, or we would look at a contour diagram and make the estimate. What can we now find though? Instead of estimating or looking at a chart, what is another way to say M in concrete fashion? Like, there's a bunch of like f sub x, and what's this going to be? Can we algebraically find those now? Yeah, we sure can. So what we're going to end up doing is using this right here. The tangent plane to surface z equals fxy at the point AB, well, you plug in AB, you find the partial at AB with respect to x, the partial at AB with respect to y, and then you have x minus a and y minus b. It's the exact same formula you had before, but now instead of estimating the change for x, we can find it exactly. We can find the actual partial with respect to x and the actual partial with respect to y. So let's do one of them and then look at a picture. Let's do one of them. And so we found the local linearization in example 1. I want you to use those local linearizations to estimate these two values. So estimate those two values and then compare your answers to the true values. What do you need to use to find the true values? Calculator. So you can use, some people are like, how do I get the actual value if I don't? Yes, I understand it feels like you're defeating the purpose by making an estimate and then finding the actual value, but this is to prove a comparative point. How good are the estimates? So try that right now. Finish example 2 right now. Do